Hey everyone, welcome back to my channel. Today, we're diving into an intriguing topic, the silent storm, coronal mass ejections, and their impact on modern society. Let's explore how CMEs can wreak havoc on our power grids, navigation systems, radio communications, and satellite operations. The sun, a seemingly constant source of light and life, harbors a dynamic and turbulent nature. Among its many solar activities, coronal mass ejections (CMEs) are particularly significant due to their potential to disrupt our technologically dependent society. The power grid under siege. The invisible threat to our electrical lifelines pose a serious threat to electrical power grids worldwide. These massive bursts of solar, wind, and magnetic fields can induce geomagnetic storms capable of distorting Earth's magnetic field. This distortion can generate damaging electrical currents in power lines, transformers, and other components of the electrical grid, leading to widespread power outages. Navigation systems, the hidden vulnerability. When compasses fail navigation systems, particularly those relying on geomagnetic orientation, are at risk during CME events. The disturbances in Earth's magnetic field can cause significant deviations in navigational readings, leading to disorientation and potential hazards in both maritime and aerial travel. Radio communications, static over the airwaves, disrupted signals, and lost connection high-frequency radio communications, which are crucial for aviation, emergency services, and remote communications, can be severely disrupted by CMEs. The ionospheric disturbances can lead to signal degradation or complete blackout periods. Satellite operations, orbits in jeopardy, the fragile network above satellites, the backbone of global communications and Earth observation, are not immune to the effects of CMEs. The increased radiation and charged particles can damage satellite components, disrupt signals, and even alter satellite orbits, posing risks to GPS services and other critical satellite-based systems. The ripple effect on technology, a cascade of technological troubles. The impact of CMEs extends to various facets of technology. From the potential loss of critical data to the failure of safety systems, the ripple effect can be profound. The reliance on technology in everyday life means that even a minor disruption can have significant consequences. Imagine a massive solar storm like the one experienced during the Carrington event in 1859. The resulting coronal mass ejection CME caused telegraph systems to spark and short out, throwing communications into chaos. Thankfully, we have more resilient power grids today, but CMEs still pose a threat to electrical power grids worldwide. Modern society is heavily dependent on satellites for navigation systems, radio communications, and other essential services. A powerful CME could disrupt these systems without warning, leaving us vulnerable in the face of such a storm. While solar storms aren't a direct threat to life on Earth, their impact on society could be catastrophic. The last major storm happened in 1859, leading to widespread telegraph disruptions around the world for weeks at a time. Just imagine how advanced technology would fare today. What precautions can we take to mitigate the impact of future solar storms? To mitigate the impact of future solar storms, we can take several precautions. Enhance prediction and monitoring. Improving the forecasting of solar storms is crucial. This involves investing in space weather research and monitoring systems to provide timely warnings. Strengthen infrastructure. Power grids can be hardened against geomagnetic storms, which may include upgrading transformers and installing protective systems to manage sudden electrical surges. Satellite protection. Designing satellites with more robust shielding and incorporating failsafes to protect against the increased radiation and charged particles during solar storms. Communication systems. Developing backup communication networks that can remain operational or quickly recover in the event of a solar storm-induced disruption. Public awareness. Educating the public and relevant industries about the potential risks and the importance of preparedness for solar storms. International collaboration. Working with international partners to share data and strategies for dealing with the global challenge posed by solar storms. Personal preparedness. Individuals can prepare for potential disruptions by having emergency supplies, alternative power sources like generators or solar panels, and staying informed about space weather alerts. These measures can help reduce the vulnerability of critical systems and ensure a more resilient response to the challenges posed by solar activity. The Carrington event highlights that we might not be as prepared as we think for another major solar storm. Climate changes caused by solar activity are often overlooked when discussing climate change today. But solar activity does influence Earth's climate through effects on the ozone layer. Even global temperature changes over timescales of decades or centuries. A severe CME could potentially cause an artificial ice age by destroying Earth's protective ozone layer in minutes. Advancing collaborative intelligent knowledge and readiness are keys to face powerful MCE these days and ones to come. Are you ready? Thank you for tuning into today's episode about the silent storm, coronal mass ejections, and their impact on modern society. Stay safe out there and don't forget to hit that like button and subscribe for more enlightening content.
Thank you for watching. Muito obrigado por assistir.